Okay, let's start. Let's do the 19th of April question. Number of islands. Let's do it from scratch. Okay, let's do this problem from scratch. Given an m cross n 2D binary grid which represents a map of ones which is land and zeros which is water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent land horizontally or vertically. Okay, no diagonals, only horizontally and vertically. Horizontally and vertically. Yeah. You may assume all four edges of the grid are all surrounded by water. Okay, so these edges are also surrounded by water. So this, not this, this is one chunk of land and this is one island, and there is only one, so the answer is 1. Here this is one island, this is second island. Diagonals are not connected, only horizontally and vertically. And this is the third island. Again, diagonals are not considered as connections. So yeah, let's try to look at the approach. The approach is we'll iterate to all of these, and once we get one that is not been visited previously, we'll visit all the ones that are adjacent to this one, all the ones that are in an island to this one, and then we'll increment our counter. And for zeros we'll just skip zeros. So here in this case this will be the first one that has not been visited, and then we'll visit all of them that are in the same island as this one. And once it is done, the counter will be incremented only once, because there are no more ones that are not being visited, so the answer will be 1. In this case, first we'll visit this one. If we visit this one, counter will be incremented, then we'll visit these, counter will not be incremented in that case. Then we'll go, this is visited, go through all these, this has not been visited, so we'll increment the count again. There are no adjacent lands, so we'll continue. And this one again has not been visited, so we'll visit this one also and increment the counter. So in total that will be 3. Let's see how we can implement this. And also my typing speed will be slow because I'm holding my phone for the microphone, so yeah. Okay, so we'll create a recursive substructure that is going to visit all those ones or lands that are connected to our first land. So we'll just do void. Let us see. We'll name it travel through all the lands that are connected to the land in which you are currently in. So we'll first need this grid. There's no copy option with the okay. Then we'll need a visited array. We'll keep it bool. If visited array at I comma j is 1, that means this node has been visited, or this I comma j cell has been visited already, so we don't need to do anything, right? Okay, all right. So if okay, let's see. First we'll visit I comma j, and then we'll visit first the top. For the top we'll need a condition. If if I is greater than 0, which means it is 1 2 3, because if I is 0, then we don't need to go at the top, right? So if I is greater than 0 and if I is greater than 0 and what else, I is greater than 0, okay, and grid I plus I minus 1 j. I minus 1 means we have gone one level up. If I is equal to 0, we can't go up, right? So if I is greater than 0 and grid of I minus 1 j is 1, which means it's a land, we'll visit it. Basically we'll travel on that part of the land as well. So that will be grid with I minus 1 and j. Let's do it for bottom. Conditions will be similar, not exactly same. If I is this time less than grid dot size minus 1, this is grid dot size minus 1. So if I is above this, then we can go down. We can go I plus 1 and j, and I plus 1 j should be 1, means it should be a land. If it's a 0, we don't need to go there, we can't go there. Okay, we have gone to the top, we have gone to the bottom. Now we'll go to the left. Conditions will be similar again, this time on j. If j, this is the left, right? So if j is greater than 0, then we can go to j minus 1 and grade I comma j, I comma j minus 1 is 1, then we'll travel on I and j minus 1. Similarly for right, we'll have some, oh shit, yeah, we'll have similar to this one. Our j is less than grid 0 dot size minus 1, grid 0 dot size minus 1, so we'll be able to go ij plus 1. We'll be able to travel ij plus 1. Yeah, that's it. We'll just do this. And when can we access I and j? We can access I and j if I is greater than equals to 0 and I is less than grid dot size and j is greater than equal to 0 and j is less than grid 0 dot size. Only then we'll be able to do this, right? Yeah, so this is our base condition. And yeah, basically will only be able to do this if this condition happens. So why not just do this? We'll put all these up. Oops, my bad. Okay. Okay. So if I is greater than equal to 0 and I is less than grid dot size, and j is greater than equal to 0 and j is less than grid 0 dot size, we'll be able to do these things. We'll be able to mark ij as 1. We'll be able to go at top if this condition happens. We'll be able to go at bottom if this condition happens. We'll be able to go to the left if j is greater than 0, then we will be able to go to the left, and we will be able to go to the right if j is less than grid 0 dot size minus 1. We will be able to go j plus 1. Yeah, looks correct. Let's work on the main function. Okay. Let's say int answer equals 0. Initially there are no islands, like we did not find any islands until now. Now what we'll do, we'll do a for loop. For int I equals to 0, I less than grid dot size and plus plus I. We'll have another loop for j. For int j equals 0, j less than grid 0 dot size and plus plus j. We'll do if I comma j is 1, grid I comma j is 1 and it is not yet visited. If grid I j equals to 1, character 1, and it's not yet been visited, not vis ij, then we'll travel grid vis I and j, and we'll just increment our answer once. The first time we get an unvisited cell, we'll increment our answer and visit all the cells that are adjacent or that are connected to that cell. And let's just make this vector array of vis and we'll have to initialize it because we are using it here like this, right? And here as well, because we are using it like this, we'll have to initialize it. So we'll initialize it with grid dot size and vector bool of grid 0 dot size defaulted to 0 or false. Let me just write false for your clarity. Yeah, and then after this we'll just return answer. Let's just try to run it. Let's see if we get some errors or we need some debugging. Okay, stack overflow. Let us see. We have vector bool with grid dot size, vector bool grid 0 dot size initialized to false. Int answer equals to 0. For int I equal to 0, I less than grid dot size plus plus I. Int j equal to 0. Okay, j, my bad. J less than grid 0 dot size plus plus j. Grid ij if this is 1 and it's not been visited. Yeah, now it looks fine. I hope there's no error in the travel function. Okay, let us see. Okay, so I just figured it out. What's the problem here? So the problem is because we are marking I comma j as true, and then we are traveling to top, bottom, left and right, and then we are calling travel for all of them. The thing is, suppose look at these four squares, this one, this one, this one and this one. We'll go here, we'll go to the right, we'll go here, we'll go to the bottom, we'll go here, we'll go to the left, we'll go here, we'll go to the top, and then we'll again go here, because we did not specify when not to go there. So we'll have to specify what? We'll have to specify in all these four conditions. We'll have to specify and not visited. Not visited what? In this case we should not have had visited I minus 1 j, I minus 1 and j. In this case we should not have visited I plus 1 and j. In this case I and j minus 1. Oops, my bad. And in this case I and j plus 1. Now this should work. Let us see. Now by adding this condition, this one, we are not going back to the same square again and again, so this should work. And as you can see, this has given correct result for the given test cases. Let us try to submit it, and yeah, we are able to submit it. Although the time and space complexity are not very good, but it's considerable. Yeah, so that's how you do it. Thanks.